Welcome to Science Aspects, where safety and learning go hand in hand. Before we dive into the exciting world of science, let's talk about something crucial: your safety. We've got some important rules and regulations to ensure that our time in the laboratory is both educational and safe. First, we will learn about occupational health and safety. This means taking care of ourselves and each other while in the laboratory. Following the laboratory rules and regulations helps us keep a safe and respectful environment for everyone. And in the case of an emergency, we've got general fire orders to guide us to safety. Remember, your safety is our top priority. Then finally, we will get into the exciting part, our lab sessions. Science involves a lot of hands-on work, and we'll be using various types of glassware to conduct experiments. We'll introduce you to each piece of glassware and we'll show you how to handle them safely. From beakers to test tubes, each one plays a unique role in the experiments. By following the guidelines, we'll ensure that our experiments go smoothly and safely. Get ready to embark on an exciting journey of discovery while keeping safety as our guiding star. Occupational health and safety forms the foundation of every laboratory experience. You are warned. All substances handled and operations performed in the laboratory can be hazardous or potentially hazardous. All substances must be handled with care and disposed of accordingly to laid down procedures. All operations and manipulations must be carried out in an organized and attentive manner. In order to assist you in developing good and safe laboratory techniques, a set of laboratory rules and regulations will be addressed. In this video, your attention will be drawn to the safe handling of laboratory glassware. These are specific instructions and warnings and must never be ignored. You will also need to confirm that you heard and understood the rules of the laboratory. Laboratory rules and regulations. Students must be present 10 minutes before the start of each scheduled practical session. No students will be allowed to work in the laboratory outside of the practical hours, except by express permission by staff members responsible for the practical. Never work in the laboratory on your own. Smoking is strictly prohibited in all laboratories and instrument rooms. Cell phones must be switched off when in the laboratory. Do not put anything in your mouth while working in the laboratory. Never taste or smell a chemical or a solution. Eating is strictly prohibited in all laboratories, and that includes chewing gum. All students are required to wear a laboratory lab coat, and no students will be permitted to work in the laboratory without one. All students who do not wear conventional spectacles must wear eye protection in the form of goggles. Safety glasses must be worn throughout all practical sessions. Students who wear conventional spectacles must always have them on when in the laboratory. All students must wear closed shoes in the laboratory unless express permission has been obtained to wear sandals for a medical reason. Paper towels will be provided in the laboratory to dry apparatus and clean the bench tops. Students are not allowed to enter preparation rooms. General fire orders. Firefighting instructions are exhibited in individual laboratories. However, the following orders must always be obeyed. In the event of a fire, no matter the size, always shout for help. Upon hearing a fire evacuation alarm, number 1, stop normal work immediately. Number 2, make safe any apparatus and material in use. Shut off any local gas, taps or valves, and electrical appliances at your bench and any other potentially dangerous services under your control. Number 3, pay attention to your demonstrators who will guide you out of the building safely to the assembly point. And finally, number 4, at the assembly point, a register will be taken to ensure everyone is out of the building safely. Introduction to lab sessions. In these laboratory classes, you will have the opportunity to learn about some practical aspects of your science curriculum. All sciences have to perform experiments or assessments at some point in time, and these will be much more successful if they are done with some understanding of the procedures. This video and your manual contains all you will need to carry out the experiment successfully. It is hoped that the background information is both helpful and interesting. You must be aware of the experiments you are doing and on which particular day. You will get much more out of the session if you watch this video and read the manual before you come into the practical class. If you do not understand something, then ask at the beginning of each practical session. If at any point you do not understand, stop and think, and then if you're still having a problem, ask. The laboratory experiments are intended to illustrate some of the scientific experiments that are foundational to every scientist, and also to give you a chance to develop some scientific skills. You should try to perform these experiments as carefully as you can. Marks will be given for accuracy as well as calculations and comprehension. If you work at these practicals, then the coursework will become easier, and if that's easier, then the tests and the exams will also be easier. Notebooks. A professional scientist always uses a laboratory notebook to maintain a permanent and original record of the experimental observations. The emphasis in such a notebook is on keeping an immediate and faithful record of the laboratory observation, and not primarily on neatness. A pen should always be used for writing on it and not pencil. Data and observations should be recorded in the notebook as they are collected and before any calculations are performed. Details of calculations should also be entered. Any errors should not be erased or painted over with Tipp-Ex. Drawing a line through an error is sufficient to show that you recognized it as an error, but will still allow the information to be seen in case it turns out not to have been an error after all. Reports, publication, and even legal testimony may be based ultimately on such data. Never record data on loose sheets of paper. Welcome to today's laboratory session. In this session, we will introduce you to some essential laboratory equipment that scientists use every day. These basic laboratory tools are building blocks for the scientific experiments. Understanding how to use them correctly is crucial for your success in the lab. Remember, safety is top priority when using glassware. Always follow the safety guidelines, wear protective gear, and handle them carefully to avoid accidents. Now, let's start with the most iconic piece of lab equipment, the test tube. The test tube is a cylindrical glass or plastic container with a narrow opening at the top and a round bottom. They are typically made from borosilicate glass, which is resistant to heat and chemicals, which means you can heat and cool them without breaking them. They come in a variety of sizes, ranging from small to large, in order to accommodate the different volumes of liquids or solids. Test tubes are widely used in laboratories for mixing and reacting chemicals in controlled environments, observing chemical reactions and color changes, heating substances over a Bunsen burner or a water bath. They are also great for storing small quantities of substances for future analysis. Don't be fooled, however. Glass test tubes are still fragile and prone to breakage. They need to be handled with care in order to avoid this breakage. Do not use cracked or chipped test tubes. And remember, always wear appropriate protective gear such as safety goggles and gloves when working with chemicals in test tubes. When you are done conducting the experiments in your test tubes, you will need to clean them, and the test tube brush is the handy tool for the job. A test tube brush is like a mini broom for your test tube. And just like a broom, it has a long thin handle with bristles at one end. You use these to clean the inside of your test tube. The bristles are usually made from nylon or other type of synthetic material, and the handle is often made from plastic or wood for a good grip. Remember that the bristles are synthetic and may degrade over time with the use of harsh chemicals. The brushes come in various sizes to match the different test tube diameters. But why is cleaning important? Cleaning will remove the residue of the stains from your previous experiments without scratching the surface of the glass. This is to avoid contaminating your future experiments. To use the test tube brush, simply insert the brush into the test tube and scrub away. Rinse thoroughly with water after cleaning and store the brushes in a clean and dry place. The test tube cannot stand on its own since it has a round bottom. So for that reason, we have the test tube rack. The main job of the test tube rack is to hold the tubes upright during experiments and therefore avoiding spills. It also allows for the easy access of contents to multiple test tubes simultaneously. They are typically made from plastic or metal and come in various sizes to accommodate the different numbers and sizes of tubes. The metal stands offer some sturdiness and durability, whereas the plastic stands are lightweight and resistant to corrosion. The choice really depends on the laboratory preference and the needs for stability. To use safely, place the test tube securely in the stand, ensuring that they are stable and will not tip over. Always place the test tube stand on a flat, stable surface. Choose a stand with the appropriate number of slots for your experiment. Now let's talk about beakers. Beakers are cylindrical containers with a spout and they have a flat bottom. Scientists like to use beakers for a wide range of tasks like mixing and stirring solutions, pouring liquids into other containers, and heating liquids over a Bunsen burner or a hot plate. They are available in a variety of sizes. They range from as small as 5 mm and as large as several liters. A size is chosen to fit the needs of the lab at a particular time. However, they are not the best choice for precise measurements. They have volume markings, and these are known as graduations, but they are only rough estimates of the liquid volume. Beakers can be made from borosilicate glass or various types of plastic. The advantages of a glass beaker is that it is transparent and it is resistant to heat and chemicals. Plastic beakers, on the other hand, are lightweight and shatterproof, and these are ideal for non-heating applications. Up next is the Erlenmeyer flask. These are cone-shaped bottles with a narrow neck and a flat base. They are usually made of glass. Scientists love Erlenmeyer flasks because they are great for containing reactions and preventing splashes. So for the most part, scientists use them for mixing and swirling solutions without spilling. Containing reactions that might produce a gas or a splash, such as a titration. As with beakers, Erlenmeyer flasks come with different sizes and are perfect for experiments where you need to measure volumes approximately. The volume markings should not be considered as accurate. Erlenmeyer flasks are typically made from borosilicate glass or various types of plastic. The glass Erlenmeyer flasks are heat resistant and can withstand vacuum pressure. The plastic versions again are lightweight and suitable for non-heating applications. Now let's talk about the precision tool of the laboratory, the volumetric flask. A volumetric flask is a slender, pear-shaped container with a precise volume marking on its neck that indicates the exact level at which the volume of the liquid is equal to the volume that is written on the outside of the flask. It's typically made of glass but also comes in plastic. It can be clear or it can be amber. Volumetric flasks come in a variety of sizes, but each is designed for one specific volume, making them ideal for an accurate measurements. The disposable pipette. This is a small plastic tube with a small bulb at one end. Plastic pipettes are disposable and convenient for avoiding cross-contamination and are very useful for transferring liquids in a dropwise manner. Just like a normal pipette, disposable pipettes are used for transferring liquids, particularly small volumes of liquids. And they're also a quick and easy liquid transfer during experiments. A graduated pipette is like a long slender tube with a volume marking along its length. It's used for precise liquid measurements. Lastly, let's introduce you to a simple but effective tool, the medicine dropper. It is a small, thin tube with a detachable rubber bulb. While it's not a high-tech lab instrument, a medicine dropper is incredibly useful for many tasks, such as adding small drops of liquids to an experiment, handling tiny volumes of liquids with precision, and conducting simple chemistry experiments. Medicine droppers are readily available in laboratories and can be used in various everyday scenarios. They are typically made from glass or plastic. The glass medicine dropper will be chemically resistant, while the plastic dropper will be lightweight and suitable for non-laboratory applications. As with every piece of glassware we have shown you today, the choice of material for each type of glassware will depend on factors like heat resistance, chemical compatibility, and intended use. While glass offers transparency and robustness, plastic alternatives provide shatterproof convenience. Selecting the appropriate material ensures safety, accuracy, and efficiency of laboratory experiments. Remember to handle all equipment with care and adhere to safety protocols when working in the laboratory. Stay safe, stay curious, and enjoy your scientific explorations.